From the devices in our pockets to the cars we drive, and even the electricity that powers our homes, batteries are the silent force behind our modern world. But what are batteries? How did they come to shape the 21st century? And where is the future of energy storage headed? The story of batteries begins in 1799 with Alessandro Volta, the Italian scientist who created the first true battery, known as the voltaic pile. It was made of alternating layers of zinc and copper, separated by brine-soaked cloth. Volta's invention provided the first continuous and reliable source of electricity, a breakthrough that would revolutionize science and technology. Before Volta's invention, electricity could only be generated briefly and unpredictably. The battery changed everything. It allowed scientists to experiment with a consistent electrical current and opened the doors to modern chemistry, electromagnetism, and eventually, the invention of the electric motor. Over the next 2 centuries, battery technology continued to evolve. The development of the lead-acid battery in 1859 made it possible to store larger amounts of energy, eventually powering the first electric vehicles in the early 1900s. At their core, batteries are devices that store chemical energy and convert it into electrical energy. But how does that work? Look, this is an atom, the most basic unit of every substance of the universe. Everything in this world is made up of atoms, and the basic structure of every atom is the same. It is such that in the middle of the atom there is a nucleus which contains neutrons and protons. It is positivity comes. This means that there is no charge on neutrons, they are neutral. But these are protons which carry positive charge. Thus, in the center of nucleus is the neutron, and its positivity is due to the proton. That is positive charge. And the electron gets attracted to these protons and circles it. Just understand that this nucleus is covered with protection. The one of our interests is electromagnetic force. Electric force, electric attraction between protons and electrons. Due to these forces, these electrons are bound to the nucleus. This is why the electrons are circling the nucleus. There is a bundle of neutrons and protons inside every atom of the world, and a particle named electron is circling it. Now, differentiation is due to how big this nucleus is and how many electrons are roaming around it. It is a simple calculation. The more protons and neutrons there are, the bigger the nucleus will be. The more positive will be, more positively charged it would be, and the more electrons around it. The law of nature is that the positive charge of a proton and an electron's negative charge is equal. Therefore, the more protons there are in a neutral atom, the more electrons are present. And the basic identity of any atom is atomic number equals number of protons, equal electrons around the nucleus. The smallest atom in the world is the hydrogen atom, which has only 1 proton and 1 electron around it. Then comes the helium atom, which has 2 protons and 2 neutrons in it, and thus 2 electrons rotate around it. After this, lithium will come, which we will discuss in detail later about its importance. Till today, our society has discovered such unique atoms as 118 elements, which represent chemical elements. Here, how these electrons will be distributed around the nucleus depends on the size of each atom. And how loyal an electron will be to this nucleus depends on how far away the electron is placed. Electrons that are close to the nucleus would be more loyal to it, and the problematic electron are placed far from the nucleus. And the loyalty depends on nucleus quantity, its position and number of electrons. Now there are 2 things apart from electromagnetic force. Finally, 2 things emerge from here. First is neutrality, that is, number of protons equals number of electrons. Second thing is reactivity, that means the far away electrons are in search of bigger nucleus, with higher possibility to attach that nucleus. Due to this flow of charge is produced. And we have read in books, this flow of charge is electricity. Let's discuss few more technical stuffs here. See, the ability of the nucleus to withdraw its electrons is called reduction potential in chemistry. That means few are in a need to give a few electrons, few are in a need to take a few electrons. And in chemistry, The process of giving up electrons of elements is called reduction potential. And it is obvious that it will be different in every atom, because the nucleus is different in each atom, different positions, and thus 118 elements have different reduction potential. Capability to attract electrons is also different. This is a list in which the reduction potential of different elements is written. To set the standard, the potential of the first element, that is the world's first and lightest element, is taken to be 0. And in comparison with that, the reduction potential of the rest is defined. Those who have higher reduction potential as compared to hydrogen, they have more positive reduction potential. Those with tendency to reject electron higher than hydrogen have negative reduction potential. The thing to note is that nucleus which have higher binding force greater the reduction potential. And the nucleus with less charge, with less attractive power, will have lesser reduction potential. In this way, depending on the reduction potential arising from the atomic structure, some elements have a tendency to give electrons and some have a tendency to take electrons. And this is relative, since the concept of reduction potential and neutrality is very simple. Therefore, the batteries prepared 1800s ago were also very simple. To generate current from these batteries, two metals with different reduction potentials were joined together in a special way. The most common metals at that time were zinc and copper. Therefore, by placing a cloth or rag soaked in salt water between them, they were arranged in a line. And the result was that when connected in series in this way, a decent voltage was generated. This was a simple setup. The reduction potential of zinc is much lower than that of copper. Therefore, when both of them are connected with a wire, the electrons will move from zinc to copper. This is what is taught to you in science books like voltaic pile, voltaic cell. See, the part that provides electrons, which in this case is zinc, is called anode. And the part with low reduction potential, which openly accepts electrons, which in this case is copper, is called cathode. The anode has capability to give and cathode have capability to accept. Now you might be thinking, there is a cloth/rag of salt water in the middle. What is the scene of this? Look, it is called electrolyte. And this is a very important part of the battery, because it is used to maintain neutrality. And this electrolyte plays a revolutionary role in this. See what happens when an atom loses an electron, it gets a net positive charge. Earlier there were equal number of electrons and protons, so it was neutral. Anode net positive charge, but now if one negative electron goes, the total positive ones will increase. Similarly, on the other side, the one that accepts the electron will get a negative charge called cathode net negative charge. Now these are no longer ordinary atoms. These are called ions. Any charged atom or molecule is called an ion in chemistry. Be it positive or negative charge, if it carries a charge, it will be called an ion. Some ions exchange electrons as soon as they get the chance, but the rest become a big problem for the electron flow of the battery. The more atoms separate electrons from the anode, the more the positive charge will increase. And as more atoms on the cathode take electrons, the negative charge there will increase there, due to increase in the number of these ions. If these ions continue to accumulate at the cathode and anode, after some time, they will become an obstacle to the flow of electrons. By creating a positive charge on the anode, it will prevent other electrons from passing through. And due to increase in negative charge on the cathode, it will push the incoming electrons. So, after some time, the current generation from the battery will stop. Therefore, this electrolyte has been arranged. This electrolyte is a medium from where ions can flow freely. So as soon as positively charged ions are produced at the anode, they will be drawn towards the anode, passing through this electrolyte, collecting negative charge on the other side. A charge balance is maintained. The electrolyte works to balance the charge. Balance of neutrality and reactivity. This balance maintains the electric potential for a long time, and the battery continues to supply current until it is completely exhausted. This is working mechanism of each battery in world. Potential or voltage, V, and current, A. These are two technical terms. People who do not understand electricity can understand it with the analogy of a water tank. Water tank and batteries are quite similar. Here we have gravitational force and their electric forces. Water flows from water tank and charge flows from electric tank batteries. Higher the tank, better the flow due to higher gravitational potential. Higher electric potential leads to higher capacity of battery to flow current. But with higher capacity, higher delivery isn't promised. We have to realize the potential. Realized potential is the current. Actually, there are multiple factors affecting water flow regardless of height. Similarly, there are factors in battery, such as cathode and anode, apart from potential. Just make two things clear: potential is capacity and current is flow. Electric potential is the capacity and electric current is the actual flow. See, this terminology and working mechanism applies to all the batteries equally. Difference of Rp between anode and cathode, and flow of electrons due to this, and electrolyte to balance the ions. Pick up any cell battery. There are these four things behind it. We're working on next-generation batteries like solid-state batteries, which replace the liquid electrolyte with a solid material. These could potentially store more energy, charge faster, and be safer than current lithium-ion technology. Batteries are the quiet workhorses of modern life, powering the devices and technologies that define our era. As we stand on the brink of a new energy revolution, batteries will continue to evolve, becoming more efficient, more sustainable, and more critical to our future. In a world increasingly driven by technology, batteries are more than just a convenience. They're the key to a sustainable, electrified future.